Hey everyone, welcome to another Con Support video. This one's on recognizing functions from tables. It's an 8th grade skill. Alright, so basically remember what a function is. So a function is any relationship where one variable is dependent on the other, and one of the variables is an independent variable, the other one's a dependent variable. And the independent variable is like, let's say x, for example, is an example of an independent variable. For every independent variable, there is only one, expected dependent variable. So every time you put the same input in, you should only get one expected output. So like if you input a 1 to the function rule, then the output, let's say, is a 5. Every time you input a 1, the output should be a 5. There's no situation where for one input there are two outputs or more outputs. All right, so let's investigate this. It says, Erica chops wood in the forest. The table compares the number of cans of insect repellent Erica uses and the number of mosquito bites she gets each day. Can the number of mosquito bites be represented as a function of the amount of repellent used? Okay, so what you're looking for here is it's the number of mosquito bites, that's the output, okay, represented as a function of the amount of repellent used. So cans of repellent is going to be your input, mosquito bites is going to be your output. You're looking first of all to see if there's any situation where the inputs are the same. So you have 1, 5, 4, 2, 4, 3, 2. Notice the 2's, right? You have the 2 of the same inputs, right? Now, whenever you have 2 of the same inputs, if this is going to be a function, there has to be the same output. So if you have a duplicate input, you have to have the exact same output for both of them. And so here we have the order pair 2, 9, and here we have the order pair 2, 9. So every time you put a 2 in, it looks like you're getting a 9 out. Now, I don't know what the rule for this function is, but what I do know is that for every single input that they've generated, there is only one output that goes with it. So this is a function. Okay, in this situation, it says the table lists the government ministers of the legendary kingdom of Neverland. Okay, can the government offices, I should say, be represented as a function of the ministers' names? All right, so the office is the output, ministers' names is the input. For every input, there should be one expected output. So if you see a duplicate input, that duplicate input should have the same output. So Peter was president, Wendy was education, John was defense, Michael was foreign affairs, Wendy was health, Toodles was finance. Peter, duplicate, right, should be what he was originally. What was he originally? He was president. This is Peter was justice as well. Can this same input have different outputs? Not if it's a function. If it's a function, for the same input, you have to have the same expected output. One output for every input. All right, so this is a no. Okay, so I think we get the idea at this point, right? Can the time it takes to fully charge the battery be represented as a function of the battery's capacity when the charging begins? Okay, so that means the independent variable is your initial capacity. The dependent variable is your time to charge. So you're going to input initial capacity and output time to charge. Let's see. Can the time it takes to fully charge the battery be represented as a function of the battery's capacity? Yeah, that's right. So x is the left and y is the right. So you're looking at the x here and you're asking yourself, are there any duplicates? So I see 65, 40, 30, 45, 65. So the 65 is a duplicate, okay? So once I know that I have the duplicate here, 65, that means that the outputs need to be the same. Look, you got 20 for the first one, but 18 for the second. So I already know it's not a function because for the same inputs, we have different outputs. I'm looking also at the 30, and I noticed that that's got 34 and 32. Same input, different outputs. So in two cases, we've proven this is not a function. Can the number of people who visited the park be represented as a function of the daily average temperature? So the daily average temperature is going to be your input, and the number of people visiting the park is going to be your output. So once again, the left value here is your input, your x, and the right value here is your output, your y. For every input, there should be one expected output. So 12, 16, 11, 16, 15, 17, 8, 11. I noticed the 12 and, the 16 and the 16 are the same. So for the same input, you have to have the exact same output that you expect. So you put a 16 in, you get 27 out. You put a 16 in, you get another 27 out. Every time you put a 16 in, it looks like you're going to get 27 out. So that's pretty good. I also noticed that we got 11 and you've got 11 here. So we put 11 in the first time, you get 17 out. Put 11 in the second time, you get that same expected 17 out. So every time you put an 11, you're getting a 17 out. So it looks like in the two cases that I've noticed here with duplicate x's, we have the expected outputs, right? One expected output for every input. So this is yes. And that's all you got to do for functions. Is it a function? It's a function as long as for every input there is one expected output.